Good day, sir. My name is Victor and welcome to our group presentation for Assignment 2, the Group Critique of Scientific Literature. The article we are critiquing today is a 2025 study by Jocelyn and Brinklow from the University of Birmingham, published in the Proceedings of the Institute of Mechanical Engineers. The study uses a computer simulations to examine how the positioning of a Formula One rear wing affects the overall aerodynamic performance of a car. Specifically, how small changes in the wing affects the overall performance and grip the car generates. Now, I will hand over to Dance to begin our critique.
Thank you, Victor. Starting with the research question, we found it to be clearly defined. The study asks a specific question: how does changing the rear wing's angle, height, and position affect the car's overall downforce? That specificity is exactly what a good research question needs, and it addresses a real gap in public knowledge, since Formula One teams almost never share their aerodynamic findings publicly. On the methods, the computer simulation approach is well suited to this type of research. The authors made careful, well-justified choices throughout, including a quality check to confirm their simulation was stable and accurate before drawing any conclusions. While the model does have simplifications, such as not simulating moving wheels, these are standard compromises in this type of study and do not affect the overall conclusions. I will pass on to Alauddin, who will assess the results and limitations.
Alright, thank you, Des. I will move to the results. On the results, the findings are clear and well supported. The most striking result is that moving the rear wing just 100mm further back along the car increased the car underbody grip by 29%. The study also found that activating DRS, a system that reduces the rear wing angle to allow higher straight line speed, actually reduces the car total grip by over 55%, showing that the rear wings affect the entire car aerodynamic and not jet itself. These findings are significant and also a practical findings. On limitation, the authors are honest about this. The simulation does not include rotating wheels or moving road surface, and there was no physical wind tunnel testing to verify the results. These are genuine gaps, but they are typical of this kind of study and do not invalidate the trends that the author identified. I will now pass to Auyan.
Thank you, Alauddin. On significance, we believe that this study is genuinely important. Formula One is one of the most advanced engineering environments in the world, yet none of what teams discover is made public. This study fills that gap. The finding that a tiny 100mm position change produces a 29% performance improvements tells engineers that every component must be considered as part of a whole system, not in isolation. That is a principle that applies beyond motorsport to road cars, aircraft, and drones as well. On the ethics side, there are no concerns arise. This research is entirely computer-based, and it involves no human subjects and was published openly with no conflicts of interest declared. I will now hand over to Amsha for the conclusion.
Thank you, Auyan. Now, I will deliver our group's final verdict. Overall, our group is satisfied that this study is reliable and well conducted. The methods are appropriate, the results are clearly supported, and the authors are honest about where the study falls short. The simplifications in the model are reasonable and do not undermine the core findings. What we find most valuable about this study is its central message, that in aerodynamics, nothing works in isolation. Every component affects everything else. That insight, backed by real data, is what makes this study worth reading. We recommend it as a credible and accessible study for anyone working in vehicle or aerospace engineering. On behalf of all 5 of us, thank you for watching.